Welcome to the College Neuro Network, a podcast series part of Simply Neuroscience's The Synapse. My name is Sasha.
And my name is Sarah, and we're your hosts for today's episode. The College Neuro Network has discussions with undergraduate students studying neuroscience and neuroscience professors in order to gain insight into the neuroscience department and opportunities of the nation's top universities. Today's episode is focused on Princeton University, a world research university with the heart of a small liberal arts college. With its commitment to undergraduates, built-in research opportunities, and a diverse student body that boasts students from all 50 states and over 100 countries, Princeton ranks #1 in national universities by the U.S. News and World Report.
Today, joining us is Professor Kastner, a professor of psychology and neuroscience at Princeton University. She teaches an Introduction to Clinical Neuropsychology course and Primate Posterior Parietal Cortex course. A couple of other impressive hats she wears include the scientific director of Princeton's Neuroimaging Facility, a fellow of the American Psychological Society, and editor-in-chief of Progress in Neurobiology and Frontiers for Young Minds. Welcome, Professor Kastner. Thank you so much for joining us today to discuss your experiences at Princeton.
Well, thank you for having me. It's really my pleasure.
So first, we wanted to start off by asking if you could introduce yourself and tell us a little bit about your neuroscience and psychology journey and also your responsibilities as a professor.
So I'm a professor of psychology and neuroscience, but my original training is actually in medicine. So I'm an MD, and then I received a PhD in neurophysiology, which is basically a subsection of neuroscience, if you like. So I do not have a formal psychology training, but in the way many departments were put together in the last century, neuroscience, what we call systems neuroscience, so that's the neuroscience that tries to relate neuromechanisms to behavior, was often a part of psychology, and this is why I ended up in the psychology department. And I have been at Princeton for 20 years, believe it or not. I started there as an assistant professor and then, worked my way through the ranks to a full professor, and it has been a wonderful journey. That's kind of my background. My original interest in neuroscience was actually sparked by philosophy. So I was in college, I was a philosophy major. And through philosophy, I discovered the kind of questions I was interested in. And then I decided that my journey would be to approach these questions empirically, so by doing actual experiments and studying the brain rather than by kind of reasoning and thinking about what the brain is doing.
Great. So we wanted to ask you why you chose to become a professor at Princeton University specifically.
Let me just go back a little bit so I started in Princeton, as I said, in 2000, so 20 years ago. During that time, what I was mainly doing was I was studying the human brain with functional brain imaging methods. Functional brain imaging, so functional magnetic resonance imaging that you may have heard about, was introduced to the field in the early 90s. And I was just about to finish my medical studies at the time, and I was intrigued by the opportunity to study the human brain, because fMRI in the end was really the first time to study the human brain with a great deal of insight, which would go way beyond electroencephalography, so EEG studies and so on. And I was very intrigued by that idea. And so I went to the National Institute of Health in Bethesda, close to Washington, D.C., to receive training in these imaging methods. There were only like 5 or 6 places in the world at that point in the mid-90s where you could receive that training. And so I stayed there for 4 or 5 years. And when I, wanted to move on into my own independent career as a scientist, I had a lot of opportunities, because around that time, people wanted to found imaging centers. All major universities wanted to have their own imaging center, and Princeton wanted to have one too. And there were a few established ones, and my mentors at NIH urged me to go to a center where, imaging was established. I thought it was actually much more interesting to take a challenge and to go to a place that did not have such a center and to build a center and help build a center. And this is why that was one of the attractions, really, to go for that challenge and to build something from the ground, basically. What really drew me to Princeton is a wonderful intellectual environment that this liberal arts college has, and the rich history of people like Ayaan who taught there. It's a very, very unique place intellectually, and I felt there was just no place in the US, at least the places I knew at the time, that really compared to it. So, and then I liked the small town that we're living in the vicinity of a really big town. So that was for me, a perfect setting to bring up my family and my children in this kind of quiet place with this rich intellectual context.
Great. That's actually so amazing that you were really at the forefront of construction of the neuroimaging facility at Princeton University. That's really incredible. And so our next question for you is, I know you touched on this before, but if you could elaborate on what you think makes Princeton's neuroscience department different from other top universities.
So the Neuroscience Institute was founded, I don't even know, probably 13 years ago, but for a very long time it was just, it was an entity without, there was a faculty, but the faculty was distributed across the campus and so on. And now for 6 or 7 years, we have our own building. So the Institute and the faculty now really lives in one place that has all the resources that the neuroscience program has. So the neuroscience program is a newer thing, and we have, a nice graduate program in neuroscience. We also have a graduate program in psychology that students who are interested in neuroscience can go through. So, and I, for instance, accept students from both venues. The two programs that you can choose at Princeton, that's one of the, I think, really unique things that sets Princeton aside, is that depending on whether you are more interested in relating behavior to neuromeasures of the human brain, that is mainly what the psychology program is doing. If that is your spin, you can still get a neuroscience degree, so it's a neuroscience and psychology degree. If you are more interested in really understanding the mechanistic underpinnings of how neuromechanisms relate to behavior at a much, much greater detail, which typically requires research in in laboratory animals, then the Neuroscience Institute is your home, where we basically bring together a variety of people who are really great experimentalists in different animal models, and spanning it all the way actually to the human brain, as I do in my own work, but also linking it to computation, which is really into theoretical neuroscience, which is really, really important at this moment in time, that we basically combine the vast amounts of experimental data that we produce with appropriate models that can help us to understand these data in better ways. And I think Princeton, due to its very, very strong physics and math departments and so on, is an ideal place to make these links. But again, there's so much flexibility because you have all these, different venues that you could pursue depending on what your interests are.
How are neuroscience classes at Princeton run? Are they more lecture, reading, lab, or discussion-based?
At which level? Both undergraduate and graduate, or what?
Mostly undergraduate.
Undergraduate, okay. So we have a number of different levels. So it starts in the freshman year. We have freshman seminars, which are relatively small seminar courses. And there we have, a variety of neuroscience related ones. I taught recently actually a course on the human tool maker. That's, one more peripheral thing that interests me, how we developed and this ability to become a sophisticated tool making species. That starts with, a format where we try to bring the freshmen directly into close contact with professors. Otherwise, I think during the first couple of years, A lot of college classes are big lecture classes. And then, seminars, you have senior seminars and junior seminars. Then later on, which again brings you back into this kind of smaller setting, but we have this mechanism of freshman seminars, which I think is really working well with our students. Then you take basically, if you become or want to become a neuroscience major, you take a number of introductory lecture courses that just provide you, with the appropriate background. So you have an introductory course to neuroscience, which is more cellular, synapse level based, and then we have a second course, so that's our fall course, and then in the spring you take a systems level neuroscience course, so that's more a course that tries to relate neuromechanisms to behavioral output that we produce. And then we require a small number of quantitative courses. That's a math course. Very often students fulfill that already with their AP math calculus that they come with, and a stats course typically. But that's those are the typical entry requirements for neuroscience. And once our students entering the department as juniors, everything is from the very beginning research-based. So they have a very large laboratory course that they are taking, where they're doing amazing things. They're doing intracellular recordings, patch clamping, and things like that, which is I would have loved to do that at that stage, when I was in college. But so that's a pretty nice course that the students do, and then we try to bring them into the laboratories from day one, so that they start as juniors working towards their senior thesis projects, and they do typically experiments in labs and have a very close mentorship relationship to one of the professors in the department.
That sounds amazing. As a professor, what is your favorite and least favorite part about teaching Princeton undergraduate students?
So I tell you a kind of a funny story about that. So when I was at NIH is not a teaching institution, so they do not have course offerings or anything like it. And my mentor at NIH told me that I would hate teaching because it takes so much time to prepare a good course, which is all true. If you teach big courses, then it's of course also a lot of work to make sure that all the students are on track and so on and so forth. And so I was very nervous going into teaching when I started at Princeton. And I just loved teaching, and I fell in love with it. It's actually, I had later on offers going back to research institutions that would not have teaching, and I would never consider anything like it because, my teaching is really something that I treasure. And I tell you why. What I do with my teaching is to try to pick up on topics that I know a little bit about, but where I can learn more. So I learn through my teaching as much as my students, or hopefully even more. So my clinical neuropsychology course is an example for that. I'm not a neuropsychologist, but I have clinical background. So I try to combine that to learn more about the brain that I would otherwise not do. And for instance, this course has brought me then into studies that I do with patients who have brain lesions. And so, it got me really a little bit into doing clinical research in the end as well. So I try to use my teaching really to learn more rather than to, teach something that I know very well, where I would be bored out of my mind because I know all about that, right? And if I teach something that I don't know as well, I think I'm much more open to the questions of students. And very often, I have to say, well, I don't know that answer, but I'll look it up for you. I research that because that's a really interesting question. So it gives me a little bit more of that challenge, and I just love it. The students that we have at Princeton, our undergraduates, are phenomenal. They're really, really smart kids, and it's just such a pleasure to work with them. So they're very inspiring. And, they come up with all these thought-provoking questions. And so I feel in my teaching, I learn just as much from them as they learn from me. We just learn different things, basically. And that's what I like about teaching. It's a wonderful, intellectual, curious thing to do. And so I cannot tell you anything negative. It's really true. It's just I have always enjoyed teaching, and I've never felt that it would take away from my research activities. So it's very complementary to that.
So you touched on this a little bit, but from your experience with undergraduates, what are the similar attributes that you see among successful Princeton students studying neuroscience?
I don't think that, the neuroscience students are different from the students we see in psychology. So again, since I'm in both of these departments, I have a direct comparison there. I feel like all of the students who care about brain science are very, very curious. And I think they are often very attuned to this topic because it somehow reflects on themselves, right? It's really this search that they are on, learning about their own brains, about their own behavior, that's at the root of it. So probably that sets them aside, from a chemistry or physics major. But I think in terms of curiosity, I don't think that the students are much different. So I don't think they have, traits that are much different from, from the undergraduate body per se. It's more like the motivation, what drives you. And I think very often the motivation behind this is really to understand to understand other people's minds and the behavior they produce and your own and how that is related. So I think that's a major, major motive that in talking to students runs through that.
And do you have any journal, publication, or online lecture series recommendations that aspiring neuroscientists could benefit from?
Well, a lot of the lectures that people produce are these days online. So I know that a number of my own lectures are online. So what I would suggest is MIT has a lecture series that is online. But what I would suggest is if you're interested in a topic, just research that topic. Just see, who are the people who are publishing on that topic and what do they publish? Does this really interest you? Does it spark something? And then see if you actually could just look up a lecture by, these people. And the Society for Neuroscience, which is the largest society in our field, it has, about 50,000 people in the field worldwide. They have at their annual meeting kind of broader lectures very often. So if you can get a handle on lectures like that, they may be good introductory lectures, not easy for somebody who does not have yet a lot of background, but I think enough to probably spark something and make you think, okay, I want to dig a little bit deeper. I want to read more about this topic. So there's just so much material online that I think the problem is more how do I identify the material that is relevant for what interests me? And for that, I would just, go and say, okay, if you were interested, for instance, in attention, that's the cognitive domain that I have studied for 25 years. So look up the people who really are in this area and then look at the level that interests you. Are you more a person who would like to learn about behavior measures? Are you a person who would really like to understand what the brain is doing? Are you interested in clinical aspects, in attention deficit disorder in that domain, for instance? So try to find what really interests you and narrow it down. And then I would recommend to just look at like the leading two or three people and see if you can find a good lecture by them. Because very often, and you will see that, and I think you have seen that probably in your teachers already, there is just nothing more compelling than, a good teacher, somebody who really kind of gets something to you that makes you spark. And that is what a person can do, and not a textbook or, material like that. It is typically this kind of, more personal relation that you need, basically.
Great. So you touched on a little bit how you've been studying the cognitive domain of attention. So kind of moving on more towards some questions about your research. I know your research is focused on studying how large-scale neural networks function during cognition, and you've also studied brain clutter. So we were wondering if you could expand a little more on the research you are currently conducting and the intersection between the different topics that you've conducted research on.
Yeah, so when I told you that I moved from philosophy into neuroscience, and the question when I started out was about what most people, I think, would call consciousness broadly, but I think at the time it was more about self-awareness. So how do we become, aware of our own self, of our own existence, and so on and so forth. I think that was the topic I really started out with, and I remember that I would bring this into one of the first conversations I had with my PhD mentor. And I said, I really would like to study the neurocorrelates of consciousness, and my mentor was very, very, very wise man. And he said to me, Sabine, I don't think that you will have a good future as a neuroscientist with this topic. Now, this is, of course, back in the 80s when people were not even talking about this in neuroscience. It was kind of like, okay, that's philosophy, that's not for neuroscientists. So my mentor, Otto Kreutzfeld, he convinced me that I should, what he called, study the best next thing, after considering self-awareness or consciousness, and that would be visual perception. And I had really no clue what he was talking about, to be honest, when, he first brought that up. And I asked him, so I said, why visual perception? And he said, well, you will see that actually our brain really produces what we perceive. So there is nothing there that's really it's constituted and constrained somehow by the physical properties of the world, but in the end, it is the interpretation of our brains, what we make out of that. And so he demonstrated that by giving me a number of visual illusions. And that was eye-opening to me. So I studied during my PhD studies, actually the neurocorrelates of a visual illusion to follow up on that path. And then when I started my postdoctoral training, I started attention work. And that was simply motivated by the fact that I think that we can study attention much more straightforwardly than conscious perception or consciousness. Because we have very clear paradigms where, we can quantitatively study what happens during different parts of a task and what determines the behavioral outcome at the end. And I feel that it is more straightforward than what we can do in consciousness research, but at the same time, attention and consciousness are very, very closely related because we become only conscious of things that we are attending, at least typically. There are some exceptions to that, but typically that's the case. So there's still this relation, I think, from the original motivation I had going into neuroscience, but I just have studied an area that I find more accessible in experimentation. That's my short answer to that.
Great. So we were also wondering how common it is to see undergraduate students in your lab specifically and just in labs in general on campus.
The undergraduates in my lab can really study whatever they like. So since I teach cognitive neuroscience very broadly, so I'm somebody who, so I would not be a good mentor for an undergraduate student who wants to do something at the molecular or cellular level. We have other laboratories for that. But everything that happens in cognitive neuroscience, so really in the study of the neuromechanisms that relate to any kind of cognition, doesn't have to be attention, or also sensory perception. It doesn't have to be vision. It could be, the auditory system or the somatosensory system. Undergraduates can basically pick any topic that interests them, because I feel like I can, broadly cover that field. If they become interested in, some of the ongoing projects in the lab, that is just as fine. But I had, various senior theses in my lab over the years that had really nothing to do with the ongoing work, and would just really follow the interest of the student. And I'm very happy to follow along, because typically I learned something new, but that's pretty interesting.
Yeah, and I just wanted to mention that last week we interviewed Sabrina, and she said she worked through your lab for a little bit. And she said that you were amazing to work with, and she wanted to say hi to us, and that you were one of her favorite professors. So.
Oh, thank you very much. Thank you very much. Yes, I remember her very fondly.
Okay, so we were wondering if you had any advice for the high school students listening who want to apply to Princeton to study neuroscience in the near future.
So, first of all, I would recommend to try to do an internship, not necessarily at Princeton, but at one of the colleges in a neuroscience lab, to really see what this day-to-day lab work means. A lot of students, I think, have very romantic ideas about science, but the day-to-day operation of the lab may actually not be so appealing. It may not be something where you really think, this, I can get, hooked by this, or vice versa, right? It may be just this eye-opening thing, and you say, oh my God, this is it. I really, really want to follow this, and I want to become a scientist, and that's my path. Either way, that's great, because it brings you a step forward, and then you also have something on your resume that sets you aside. Now, from other applicants. Now, not everybody has the opportunity to do that, but you could always try to study something or find an interest, and then reach out to professors and see if you can follow up on that interest with them. And I know that a lot of students try to do that, and very often they don't get replies back from professors. But I also know that there are lots of professors like myself who will answer these emails and who will try to give pointers to students to set up a Zoom meeting with them, and so on and so forth. So it's just about finding the right people, and sometimes that takes some work and patience, but it's possible. So that is what I would suggest, just to really try to develop an interest, during high school, where you can make a case for yourself why you really want to go into neuroscience, what drives that motivation, and what have you done to foster that motivation at that point. And I think that is what your professors later on will be thrilled to see. And that's the best you can do there. And I think it will weigh as much as some kind of standardized scores and other measures that college admissions people probably will look at. But this kind of drive is typically something very special.
Great, and that wraps up all our questions for you. So thank you so much for taking the time out of your very busy schedule to speak with us.
You're very, very welcome. And yeah, best of luck also with your college applications. And who knows, we may see each other at some point.
Thank you.
Take care.
Thank you. Bye.
Bye.
Bye-bye.